I spent decades staring at equations that described the first moments of everything, the universe's beginning. And I'm telling you now, almost everything you've been told about it is incomplete at best, fundamentally wrong at worst. People imagine the Big Bang as an explosion, a point in empty space that suddenly detonated, flinging matter outward into a void. I've seen 1,000 documentaries show it that way. A tiny bright spot going boom in darkness, expanding like a bomb. No, that's not what happened. There was no point in space. There was no space for a point to exist in. There was no before, in any sense you can wrap your head around. And calling it a bang, suggesting sound, suggesting an event you could witness from outside, misses what actually occurred so badly it's almost offensive to the physics. Let me show you what I spent my career discovering and what it cost me to accept. In 1967, when I was still walking, but my body had already begun its betrayal, I sat in a lecture by Dennis Sciama at Cambridge. He mentioned almost casually that general relativity, Einstein's masterpiece, predicted something disturbing. If you traced the universe's expansion backward in time, the mathematics didn't just suggest a beginning. It demanded one, not as possibility, as inevitability. The equations led to what we called a singularity, a point where density became infinite, where space-time itself ceased to have meaning, where every path through history converged into a mathematical scream. Most of my colleagues treated this as embarrassment. Surely the theory breaks down there, they said. Surely something else takes over. Surely we're missing physics that smooths it out. I became obsessed with whether the singularity was real or mathematical artifact, whether the universe actually began, or whether our equations were simply showing us the limits of what we could describe. Here's what makes this so difficult to think about clearly. When you imagine time, you imagine a line, events arranged in sequence. Before leads to after. Cause produces effect. You trace history backward like rewinding film. Galaxies moving together, the universe getting smaller and denser and hotter until you reach some moment zero where it all started. But general relativity doesn't work that way. Space-time isn't a stage where events happen. It's a physical thing that can bend and stretch and critically begin. Time itself is part of what the Big Bang created. So asking what happened before the Big Bang is like asking what's north of the North Pole. The question has grammar but no meaning. There is no before because time itself started with the expansion. The universe didn't appear in a pre-existing time or space. It brought them into existence. I spent 3 years working through the mathematics with Roger Penrose. We published the singularity theorems in 1970. They showed that if general relativity is correct, and every test we've ever done says it is, and if the universe contains the amount of matter we observe, which it clearly does, then a singularity wasn't just likely. It was inescapable. The universe had a beginning, a true beginning, not just of matter and energy, but of the arena they exist in, of causation itself. But here's where it gets truly strange. As I kept working, I realized the singularity theorems, while mathematically correct, were also physically incomplete. They described the beginning as a point of infinite density where physics breaks down entirely. And that bothered me. Not because I wanted a comfortable answer, because infinities in physics usually mean you're leaving something out. In 1983, I was invited to a conference at the Vatican. The Pope had decided the Church should make peace with cosmology. Interesting timing, given what I was about to propose would eliminate the need for creation entirely, at least in the theological sense. I'd been working on applying quantum mechanics to the universe's earliest moments. And I'd discovered something that changed how I understood the beginning. not changed whether it happened, changed what beginning means. Quantum mechanics adds uncertainty to everything. At ordinary scales, this uncertainty is negligible. But compress the entire universe down to smaller than a proton, which is where we're talking about in that first incomprehensibly tiny fraction of a second, and quantum effects dominate. Time becomes fuzzy. In quantum mechanics, you can't specify exact positions and momenta simultaneously. Heisenberg proved that. But there's another uncertainty principle equally fundamental between energy and time. The more precisely you try to pin down when something happens, the less certain the energy involved becomes, and vice versa. At the scale of the universe's beginning, time itself becomes uncertain. Not just our measurement of it, the thing itself. I proposed what I called the no-boundary proposal with Jim Hartle. The mathematics showed that if you incorporate quantum effects properly, imaginary time, a mathematical tool where time behaves like a spatial dimension, becomes real in those first moments. And in imaginary time, the distinction between time and space blurs. The universe doesn't have a sharp beginning in imaginary time. It has a smooth boundary, like the surface of a sphere. Just as the Earth's surface is finite, but has no edge, you can't fall off because there's no boundary. The universe in imaginary time is finite in extent, but has no beginning or end point. When you translate back to real time, what this means is staggering. The universe emerges from a quantum state that has temporal extent, but no definable first instant. It doesn't pop into existence. It transitions from something that isn't quite time into something that is. Let me be clear about what I'm saying and what I'm not. I'm not saying there was something before the Big Bang. I'm saying the question dissolves when you account for quantum mechanics properly. The beginning isn't a moment in time. It's a boundary in space-time that's smooth when viewed with the appropriate mathematics. This infuriated both physicists and theologians for different reasons. The physicists complained I was making time imaginary just to avoid uncomfortable infinities. They weren't entirely wrong. But the mathematics worked. It predicted a universe that started finite, expanded, matched observations. And it eliminated the singularity, not by denying the beginning, but by showing the beginning was fundamentally quantum, not classical. The theologians complained I'd removed God from creation. The Pope's science advisor mentioned this to me at dinner. If the universe has no boundary in imaginary time, he said, where does God come in? I told him that was a question for philosophy, not physics. My equations described what happened. They didn't address why there's something rather than nothing. They showed how a universe could arise from quantum laws without requiring a first cause, but they didn't explain why those laws exist or why anything follows them. Some people found this unsatisfying. I found it honest. But here's what really kept me awake, staring at my ceiling at 3 a.m. Even if the no-boundary proposal is correct, and I believed it was, though proving it remains desperately difficult, it describes the beginning only down to a certain scale. Below the Planck length, about 10 to the power of minus 35 meters, our current theories genuinely break down. Below the Planck time, about 10 to the power of minus 43 seconds, general relativity and quantum mechanics give contradictory answers. To understand the absolute beginning, we need a theory of quantum gravity, something that unifies relativity and quantum mechanics into a single framework. I spent decades working on this, focusing on what I called Euclidean quantum gravity. Others pursued string theory, loop quantum gravity, other approaches. As of my death, we still didn't have it. The mathematics was brutally difficult. Every approach that worked in some limit failed in others. So here's the humbling truth I came to accept. I could describe the universe from about 10 to the power of minus 43 seconds onward with some confidence. I could show that time and space emerged together, that there was no before, that the beginning was quantum and smooth rather than classical and sharp. But that first immeasurably tiny instant, the moment, if you can even call it that, when quantum gravity effects dominated everything, we had equations that gave hints, suggestions, possibilities, but not certainty. In 1988, I published a brief history of time. I tried to explain all this to general readers. I showed how the universe could be finite in time, but have no beginning or end, like the surface of the Earth is finite in area, but unbounded. I explained imaginary time and the no-boundary proposal. Most readers, I think, found this confusing. Fair enough. It's confusing. It requires holding two ideas simultaneously. The universe definitely began, and it has no boundary or edge to that beginning. Both true, both uncomfortable. Some accused me of atheism for removing creation. Others accused me of mysticism for using imaginary time. Both groups missed the point. I was following the mathematics wherever it led, and it led somewhere profoundly strange. By 2006, my body had deteriorated to the point where I could move only a few facial muscles. My voice had been synthesized for 2 decades. I communicated at a rate of about 1 word per minute, agonizingly slow for someone whose mind moved as fast as it ever had. And yet I kept working on the universe's beginning, not because I expected to solve it completely in my lifetime, because the questions mattered. Because each step forward in understanding felt like pushing against the same limits my body imposed, and occasionally finding cracks. Here's what I can tell you with confidence. The universe began approximately 13.8 billion years ago, not in a location but as the beginning of location itself, not at a moment but as the beginning of moments. The Big Bang wasn't an explosion in space. It was the explosion of space, of time, of physical law. In the first incomprehensibly brief instance, quantum effects dominated. The universe existed in a state where our normal concepts of time and causation don't apply. As it expanded and cooled, classical physics emerged. Space-time became smooth. Clocks started ticking, but calling this a beginning in the usual sense misleads. There was no transition from nothing to something. There was a transition from a quantum state without well-defined time to the classical universe we inhabit, from timelessness to time, from quantum foam to structured space-time. The no-boundary proposal suggests this transition was smooth and lawful, governed by the same principles that govern everything else, just at scales where quantum mechanics and gravity both matter intensely. Not magic, not violation of physics. Physics extended consistently to its natural boundary. Does this mean the universe created itself? In a sense, yes. The universe's quantum state contained within itself the seeds of classical time and space. It didn't need an external cause because causation itself is something that exists within time, not before it. There is no before. Does this mean there's no God? That's not a question physics can answer. I could describe how a universe might arise from physical law. I couldn't say why there are physical laws, or why this particular set rather than others, or why mathematics describes reality so unreasonably well. Some physicists speculate about eternal inflation creating infinite universes with different laws, only some hospitable to life. Some talk about the universe as a quantum fluctuation from nothing. Some pursue equations that might eliminate even those questions. I pursued the mathematics and tried to be honest about what it showed and what it couldn't. It showed the universe began in a way that eliminates the classical singularity. It couldn't show what, if anything, the word before might mean in a complete quantum gravity theory we don't yet have. In my final years, I wrote papers on the no-boundary proposal's implications for the multiverse. I argued that the beginning conditions it implied constrained which universes could exist and how they'd behave. I suggested it might actually be testable through subtle effects in the cosmic microwave background. I won't see those tests completed. Someone else will need to determine whether my equations described reality or just mathematical beauty that turned out to be wrong. I've been wrong before. In 1985, I made a bet with Kip Thorne about black holes. I lost. Paid up with a subscription to Penthouse magazine, which Kip's wife made him refuse. Being wrong is how science works. But here's what I believe I got right. The universe's beginning was not what most people imagine. Not a moment of creation ex nihilo. Not an explosion in pre-existing void. Not something that requires supernatural intervention to explain, though it doesn't exclude it either. The beginning was a boundary, a transition, a place where the mathematics of quantum mechanics and general relativity necessarily meet, where time itself emerges from something more fundamental, where asking what caused this stops making sense, not because we lack answers, but because the question reaches the limit of applicability. The universe didn't need a cause. It needed quantum mechanics and general relativity. Why those laws exist rather than none, or different ones, that remains mystery. Perhaps always will. I spent my career pushing against that mystery, typing one letter at a time with a cheek muscle, exploring equations that described the first moments of everything. I found beauty in the mathematics, structure in what first appears structureless, laws extending into regimes where you'd expect chaos. The beginning of the universe was not what you think, not simpler, more strange, more quantum, more fundamental, and more honest about the limits of what we can know. When you look up at the night sky, you're looking back in time. The light from distant galaxies left billions of years ago, when the universe was younger. You're seeing deep into cosmic history, but you can't see all the way back. There's a limit, about 380,000 years after the beginning, before which the universe was too hot and dense for light to travel freely. Beyond that curtain lies the quantum beginning, the no-boundary state, the emergence of time from timelessness, the place where my equations suggest something profoundly strange occurred, but which we'll never observe directly, only infer, only describe with mathematics, only understand as clearly as our theories allow. It's enough. It has to be. The universe began. We can describe how. We may never fully answer why. And I've made my peace with that. The physics teaches what it teaches. The boundary remains, even if it's smooth in imaginary time. Our understanding reaches as far as our equations allow, then stops at the wall of quantum gravity we haven't breached. Not failure, honesty. The beginning was not what you think, and what it actually was, that's stranger and more beautiful than any simple story of creation. That strangeness cost me decades of work, left me with more questions than I started with, showed me the limits of even our best theories. I meant it then. Still do now. The universe's beginning dissolves into quantum foam at scales our current physics can't fully grasp. And that's okay. That's what's real. That's what the mathematics shows. That's what I spent my life discovering. Not the comfortable story, the true one, as far as we can tell. Strange boundaries and imaginary time and the birth of causation itself. That's how everything started, and it's magnificent.